Hello students, welcome back. We have one more example to go. And this is a bit complicated, so I'm going to go rather lightly on it. If you understand it, fine. Even if you don't, well, if you want to study a little bit further, then you can look up the notebook. But if you don't follow and if you're not that much into it, then it's alright, you can skip it. Okay, here you go. We begin with a relationship between the price and quantity. And let's answer these questions. At which point the elasticity is 1? So E is 1. And is that important? Well, I hope everybody remembers. Revenue is price times quantity. And taking the derivative implicitly, we get this conclusion. So assuming that P prime is positive, that is, price is going up, whether R prime is positive or not depends upon whether E is less than 1 or greater than 1. So basically, if you want to optimize R, that is, if you want to maximize your revenue so that R prime is equal to 0, then you're going to find out where the elasticity is equal to 1. That's why we are particularly interested in the case where elasticity is equal to 1. Okay, let's find out. And here's the solution. So, taking the derivative implicitly, we get this derivative computation, which can be simplified a little bit further like this in traditional notation. And then, of course, we are looking for Q prime over P prime. And then we can plug everything into the elasticity formula. And there you go, negative P over Q times P prime over P prime. So we get this quantity here, which we just calculated. And then P over Q come from here. So we get this computation. So we have square root times the same square root. So the square root disappears and we get something simple. Setting this equal to 1, we get, well, this quantity. Simple. And then in this particular case, Q is 200 over 3. Plug it in here and we can find out the price. Turns out like this. Okay, now find the intervals in which its elasticity is greater than 1 elastic, or the intervals in which the elasticity is less than 1 inelastic. Well, we can do this analytically, or we just found out when E is equal to 0, so we can simply find out by plugging in some values around and then see whether E is positive or negative around those. That's going to be a bit easier, but here I did it a bit hard way. E is like this, and that's less than 1, so you can solve it algebraically. So when Q is greater than that, E is greater than 1, and this is for E is less than 1, and this is for E is greater than 1. Solving algebraically. It would have been a little bit easier if you just plug in numbers. Okay, I see. The previous example, previous computation here is for the intervals about Q. And then what about the intervals of P? Well, we have PQ relation here. And then when Q is greater than this versus less than this, plug those in and do your computation about P. Then you get P is less than this quantity or greater than that quantity. You're going to get those. So in the end, we get the following conclusion. So we did this one first. E is equal to 1 when Q is this. And by plugging in, we get P value. And when do we have E less than 1? Q is greater than this, and P is less than that. And E is greater than 1, in this case, flip the direction of all those inequality. We get those. Next question. Find the values of P and Q in which the revenue is increasing, decreasing, or maximized. Okay, we're going to find out the elasticity is greater than 1 or less than 1 or 0, right? actually the other way around, increasing. So less than 1, greater than 1, or equal to 1. Oh, excuse me, this one first. Elasticity is less than 1, so revenue goes up as price goes up. Elasticity is greater than 1, so revenue goes down as price goes up. So in other words, revenue goes up as price goes down. And then we have maximum when elasticity is equal to 1. And that's the elasticity method, and that's related to part A of the problem. But you don't really need it. You can do a traditional method. So R is P times Q, and you get this expression. And you can simply take the derivative and set it equal to 0. Derivative computation, set it equal to 0. And this part is all denominator, so this is equal to 0. It's a cubic equation. You can solve it. You end up with, well, the same answer as before. Q is 200 over 3. And by plugging in this quantity over here, we get the same conclusion as before. And of course, same conclusions follow about the inequalities. You can do it through direct computation by taking the derivative without going through elasticity at all. By the way, here's a justification. If you graph it, R of Q, so let's see, P times Q, but P is by this function, so plug that in place of P, and simplify, we get this expression here, and the graph of that is like this. So it is hitting the maximum over here, about 200 over 3, 67 approximately speaking. Now what about the maximizing price? Well, P is given as function as Q, but you can solve it with respect to Q. So flip this 10 over to the other side, square both sides, and solve for Q, and you get Q as a function of P. And then revenue is P times Q, and Q is function of P. Plug in that expression, and simplify, we get this cubic expression. The graph of this cubic function is like this, and then it hits a maximum around here. 59 something was it? Same quantity we calculated before. Let's see. No, 66. Oh, no, 57, 58 or so. That was the price. And then, yeah, about 58. That's what we're looking at. So with some heavy-duty algebra, we can do this kind of problem. Each step is elementary, but everything is tedious. I don't know whether that problem is worthy for this particular class. We learned all the tools to succeed in that kind of problem, yes, and even more so because even that problem is too simplified in the sense that we have a direct function, not the implicit relation between P and Q. You could get even more complicated, but then again, it's just a math exercise at this level, so we're gonna just stop there and then draw a line, and we just did. All right, so much for section 3, and then we have 2 more sections to go, but both of them are optional sections because, well, for Calculus 1 students, these 2 are important, but for us, they're just optional topics, so you can stop everything here if you want to.